it should be a 1K water-based system. Which different film signals to apply and which difficult to applications, based on beginning by safe touch and energy saving, and on the other side coating from buildings to get an isolation effect. Okay, we start. What it is, we speak about the insulation properties, we will speak about the technology which is behind, and I will show you a small video where you see it, and we see applications, and we discuss about a special spray application we developed. What it is, what is behind the pure thermo. We have a really extreme low thermal conductivity. We have a low heat capacity, very important, and you will see it. We want to do it sprayable. It should be a 1K water-based system, but one is 1K and two are 2Ks because of instead of the stability of the aerogel inside. It should be dry by room temperature, and we don't want labeling dangerous goods or any solvent. You see inside, if we apply the film, and you see the aerogel, and you see on the other side air pores which we bring in with our special spraying unit. Okay, I went over. Yeah, this is a physical curve. It's not only specific for our pure term. That means that most of the isolation, for example, for building, are reached over the first 8-10 millimeters, and the first 8 millimeters, 10 millimeters, you have about 95% of the total isolation, and if you need the rest, you have 200 millimeters, need a lot of material to reach the rest of it. That is something on the formulation. We are working with a really special modified acrylic polymer, normally the binder aerogel with its in the world the highest insulation material. You do not get it into a waterborne system because it's absolute hydrophobic. If you put it into a water glass after half a year, you see the aerogel floating on the water. This is our knowledge how we can combine a modified and waterborne acrylic with these aerogel. We have a flash rust inhibitor in it, which we are allowed to go DTM, direct to metal, to apply. Okay, that is very important. It is technical. You see, that is the aerogel, a picture of it. It looks like frozen air. This is based on SeO2, and they're inside more than 90% air. It's very expensive. 1 kilogram of this material costs Germany more than 100 euro. And if you see, you pay for more than 90% air, more than 100 euro. This is the structure. And to go down into the 20 nanometer openings. That is very important. You will see it soon. So if you remember this structure at the next picture, you see what happened. We have a heat source here, and here is without aerogel, without the isolation material. The gas molecules, the heating gas molecules can go from down to top, and if you take here, you take a lot of these molecules and you will burn. Different is here with our coating. Yeah? If you remember the structure I told you, they are hindered. They cannot go to the top. You only took these two gas molecules, and there's nothing coming. So this is on one side a really good isolation, and on the other side a really good safety. Trust me, or? Okay, so I will show it to you. This is we have a plate, a facade plate, which has been coated with 3 millimeters of the thermo, and you see we burn it from the right corner, with a normal gas burner. The temperature inside here is about 1000 degrees. What is important, you see that it is concentrated only on this point. It doesn't spread to right, left, or to the top or to the bottom. That is a shortening. We burn more than 10 minutes. After 2 minutes, nothing happened more. Then we look here. We look for someone who put his hand on the backside. During the time we have in the front 1100 degrees. And if you remember the shot before, that's the reason. Then we turn to the back. The melting point of the metal is around 600, 700 degrees against the melt.
Which metal? Which metal?
This is a normal facet plate. I think it's a copper combination with some other zinc, zinc copper facet. So you see we are burning on the back side. The metal is fluid. To remember, on the other side are 3 millimeters only. Very simple. Okay, then we asked someone who put his hand on this side. And look, you see, give pressure on the, you see? And he puts his hand during we are burning on the other side there.
Ladies and gentlemen, that's it. That's it. Which temperature is behind? Which temperature is behind?
150.
150.
But it is not the problem. You will put your hand this afternoon on 150 degrees. And nothing happened. Okay, please be careful with this panel. You can give it around. This is an original panel from the video, and you see that the paint is already okay. And what is important here, please see, it is flexible, even after burning. Okay, so I went through some questions here. Okay, this is some theoretical why it works. These are typical applications for industrial. We speak about pipes, reactors, storage tanks, safe touch coatings, transportation, automotive, container, caravans, ship, construction, and. You can find a lot of applications, be sure. Yes, why? Why pure thermal? Because we have a personal protection safe touch. We spare a lot of energy. It is really easy to apply with a thickness up to 10 millimeters in one shot. And That's a different to systems which are on the market. Yeah, so there you can apply only 500 microns to reach 5 millimeters, for example. We have to cover it 10 times, and we make it in one shot. Yeah? We have another benefit is it's an anti-condensation. Here, if you, for example, in ships, in steel ships, you normally always have humidity, and if you cover it, you have an anti-condensation. There's nothing inside. Other application. Yeah? COE, corrosion under isolation, is the biggest market in the world. Yeah? Because of that, it's a real problem, and because of if you make a normal isolation, yeah, you put something around the pipe, and there is a space, yeah, between the isolation and the pipe. And if the factory runs and always the temperature is high, nothing happens. In the moment if they go down with the temperature, there's a condensation, there is a humidity between, yeah, and it will come rough. We have a high flexible, it is water-based and easy to application. That's something I will show this afternoon, so everybody can touch 150 degrees. Move on. We show something about the fire protection. We have prepared some panels we will burn. Yeah? Okay, insulating we have to cover. Yeah, that was one project, and with I can't name I do not allow to name the car producer here. Yeah? It's well known, and it was the problem was the heater here. Yeah, the Auspuff. I don't know. Yeah. Yeah. And the temperature here is more than 200 or 240 degrees, and we should avoid the temperature coming into this baggage room. Yeah, and normally they have a really heavy metal here to avoid the heat coming, a heat protection shield. And we did it with 3 millimeters of the cover of the thermo shield, and the problem was to integrate it into the production line because of the drying time was too. It's a technology. Here it is. Here you see the machine, and the benefit is that I told you that the aerogel is more than 100 euros and more than 90% air. That means if you realize, if it's possible to get more air into the coating, it will be cheaper because the density will go down, and the demand will even go down. And so we developed a spraying unit where we put during spraying additional air, yeah, inside. We dilute the material with air. That is the normal spraying gun. Okay, that is a summary. Yeah, we have the formulation based on new raw materials. We can easily applicate by spraying, rolling, or knife. It's drying by room temperature. It doesn't need any temperature. Very good insulation, excellent adhesion. Really, it sticks on everything you will try. And the specialized spraying equipment is commercial. Okay, thank you for your attention.
Ladies and gentlemen, Joachim Müller. And now, I would love to say the number of the song coming up to showtime. So, to introduce you